Question 14.56, you need to add an extra row to your table. So you've got A, you've got R, slash times 10 to the minus 15 metres, and then you need to have A to the power of a third. So you need to work out in your table what A to the power of a third is. Your graph should then have R on this axis, and you should have A to the power of a third on this axis here, and you should have a nice straight line. Now if we go back to our original equation, I equals R naught A to the power of a third, you can see that we plotted this on our y-axis, so we want that on the left hand side, and R, and then we want to get what we're plotting on our y-axis on its own. So you get A to the power of a third equals 1 over R naught R, which is what we're plotting on our x-axis. So that's our x, that's our m, and that's our y. So we should have a straight line with no positive intercept there. So that's just gone off the bottom of the screen. There. So you should then plot your graph. You should take a nice big triangle, and you should work out dy by dx, and that is equal to 1 over r naught. So r naught, if we take the reciprocal of both sides, is equal to the reciprocal of your gradient, which if you plot this data, you should get a reciprocal of the gradient equal to 1.0 times 10 to the minus 15 meters, which is equal to 1 femtometer. Part C asks us to calculate the radii of these different nuclei. The first one being sodium here. So we go R equals R naught A to the power of a third. R naught is what we calculated from the graph, which is 1.0 times 10 to the minus 15, multiplied by A. Now A is the nucleon number. The number of nucleons is 23 in sodium to the power of a third. And you should get 2.8 times 10 to the minus 15 meters. Do the same for silver here. R equals R naught A to the power of a third, 1.0 times 10 to the minus 15 multiplied by 107 to the power of a third, and you should get 4.7 times 10 to the minus 15 meters. You can do this another way. You can just leave it in terms of femtometers. So the other way of doing it is R equals R naught A to the power of a third, which is equal to 1 femtometer multiplied by 107 to the power of a third. So you can just leave it in that, and then you write your final answer in terms of femtometers. It's going to be 4.7 femtometers.